I am Dr. Miriam Rosenberg-Lee, and I'm an assistant professor in the Department of Psychology at Rutgers University in Newark. As April is Autism Awareness Month, I thought I'd take this opportunity to share some of my work. My primary research focus is math cognition. That is, I want to understand how the brain accomplishes this uniquely human task of mathematics. My first interest in autism came when I was a postdoc at Stanford University, and there I was studying the brain basis of mathematical learning disabilities, or dyscalculia. And I was intrigued by the possibility that math might be an area of preserved or even enhanced ability in autism. And in our first study, that is what we found. We found that children with autism had higher math scores and more sophisticated strategy use when solving arithmetic problems than their neurotypical peers. When we put them in the scanner, we were able to see that they had the same levels of activity as their neurotypical peers, but different patterns of activity. And in fact, we could look at an area called the fusiform gyrus. This is an area that's important for processing faces. And we could actually predict, based on their activity when they were solving math problems, whether a child was a neurotypical child or a child with autism. Building on this work, I was able to secure funding from the National Institutes of Health to study math learning in autism. And here we developed a training program to study the development of memorizing math facts. And what we found is that, again, children with autism and neurotypicals could learn just as well, and they had similar levels of activity, but differences in the pattern. And here we found that with learning, their brain's activity was more stable than the neurotypical ones. That is, they stayed more similar even as their behavior was improving. Since coming to Rutgers, I've been working with my colleague, Dr. William Graves, in the Department of Psychology, and we've been interested in language and reading processing in autism. And again, we focused on potential areas of strength. In this case, the ability to decode words, to figure out the sounds that go with the letters. And also, we've been reevaluating this assumption that mathematics is only an area of strength in autism. And there have been recent studies finding that in addition to mathematical talent, there's also higher rates of mathematical disability in this group. So we want to try to understand, how does a brain with autism result in both potentially enhanced math and lower math across individuals. So we've been using a technique called resting state functional connectivity to look at the way that different brain regions are communicating and see how that relates to math ability. And again, we're finding differences in the patterns, in this case, of connectivity between neurotypical adults and adults with autism. So this work is really just at the beginning, but we are finding consistent patterns of differences in activity and connectivity that help us understand how brain organization is altered in people with autism to support their academic skills. Thank you.